Now let us talk about interview or VIVA questions. Few questions on software metrics. So the question may be, what is meant by measures and metrics? So measures are quantitatively unit defined elements, for example hours, kilometers, etc. While the metrics are basically comprised of more than one measure. For instance, we can have metrics such as kilometer per hour, meter per second, etc. So measure can be kilometer, hours, meters, seconds. While the metrics, they are a combination of these, and they can be in kilometer per hour or meter per second. Can you explain unit and system test DRE? Well, we'll be going to this question shortly. This question, can you explain DRE? So let us see this first. Can you explain DRE? DRE is defect removal efficiency. DRE is defect removal efficiency. This is a powerful metric used to measure test effectiveness, whether the test was effective or not. So for this metric, we come to know how many bugs we found from the set of bugs which we would have found. So this uses this formula, which I am just going to show you for calculating DRE. We need two inputs for calculating this metric. First is the number of bugs found during development and the number of defects detected at the end user, right? Bug at the development and defects which is at the end user. You know the difference between bugs and defect? Bug is when the system is not delivered to the user, the errors are bugs, and when it is being delivered to the user, those bugs or those errors are termed as defects. So this is how we compute DRE, and DRE was defect removal efficiency. So DRE is number of bugs while testing divided by number of bugs while testing plus number of bugs found by the user. So the number of bugs while testing is equal to bug found during development, processing while testing it, and number of the bugs found by the user means these are the defect. Now they have changed into defect detected by the end user. But the success of DRE depends on various factors. Some of them are severity of and distribution of bugs must be taken into account, and how do we confirm when the customer has found all the bugs. This is normally achieved by looking at the history of the customer. Okay, so now let's go back to our this previous question which I was suggesting. Can you explain unit and system test DRE? So DRE, as we have already seen, is also useful to measure the effectiveness of particular tests such as acceptance, unit and system test. So these we'll just see a figure which shows defect numbers at various software life cycles or software life cycle levels. So the first will indicate, I'll show you, this will indicate that defects are input at the phase, and the other one will indicate that these many defects were removed from the particular case. For example, if we go here and we see this diagram, 100, these are 100 plus requirement and 20 has been removed. So only 80 are remaining, so 20 are being added and 10 are removed. So this is how it goes. So at each and every level, these are the plus shows this defect injected at that phase, and this minus says the defect removed from that phase. So now get back to our explanation. So we've seen that it indicates that defects are input at the phase, and second indicates that these many defects were removed. Plus and minus, actually these are plus and minus. For example, we have seen that 100 defects were present, but 20 defects were removed in the requirement phase due to code review. So if 20 are removed, then 80 defects get carried to the new phase, and so on. This is how they are carried up. So we need to see how maximum we want to get rid of, and for that DRE, that is the defect removal efficiency, is very important. Now we are ready for our next question. That is question number 4. So this is, can you explain defect age and defect spoilage? For that, defect age is also called as phase age or phage. One of the most important things to remember in testing is that later we find a defect, the more it cost to fix it. So defect age and defect spoilage matrix work with the same fundamental, that is how late you have found the defect. So the first thing we need to define is what the scale of the defect age according to the phases. So for instance, there is a table which is just coming. It defines the scale according to the phases like this. So for instance, a requirement defect if found in the design phase, right? If it is found in the design phase, have a scale of 1. Requirement phase at the design stage, this has a scale of 1. And the same defect, if propagated until the production phase, the scale goes up to 4. So once the scale is decided, now we can find the defect spoilage. Okay, once the scale we have decided, now we can find the defect spoilage. Defect spoilage is defects from the previous phase multiplied by this scale. For instance, in the following figure we just saw, we have found 8 defects in the design phase, from which 4 defects are propagated from the requirement phase. So we multiply 4 defects with the scale defined in the previous table, so we get the value of 4. So in the same fashion, we can calculate all the phases, and this is the formula. The spoilage will be sum of number of defects into discovered phase by total number of defects. Now the other questions can you explain how the number of production defects is measured? This is one of the most effective measures. The number of defects found in a production is recorded. The only issue with this measure is it can have latent and masked defect also, which can give us the wrong value regarding software quality. Now you can have one more question. Can you explain defect seeding? Defect seeding is a technique that was developed to estimate the number of defects resident in a piece of software. So it's an offline technique and should not be used by everyone. The process is the following. We inject the application with defects and then see if the defect is found or not. Again, the process is we inject the application with the defects and then we see if the defect is found or not. So for instance, if we have injected 100 defects, we try to get 3 values. First how many seeded defects were discovered, how many were not discovered, and how many new defects are discovered unseeded. By using defect seeding, we can predict the number of defects remaining in the system. That is, we insert a defect in the code, run the application. Is the defect detected? If it is yes, it is passed. If it is not, fail it. Now we can have a question, how do you measure test effectiveness? The test effectiveness is the measure of the bug finding ability of the test. So in short, it measures how good the test were. So effectiveness is the ratio of measure of bugs found during testing to the total bugs found. Total bugs are the sum of new defects found by the user plus the bug found in the test. So this figure explains the calculation in the pictorial form. So bug which is found while testing, new defects found by the user. The total number of bugs is adding of, we can add these two we can add, and the effectiveness is that bug found in the test by total bugs found into 100. This is what we were aiming for. Thank you so much. Take care of yourself.